Welcome back to Blueprint to Reality, the channel where we turn civil engineering concepts into everyday language. Today, we're comparing two critical structural systems used to resist lateral forces like wind and earthquakes, braced frames and moment-resisting frames. Let's dive into how these systems work and when you should use each one. What is a brace frame? First up, the braced frame system. In this system, diagonal braces are added between columns and beams to form triangular structures that provide lateral stability. These braces create a stiff structure, allowing the building to resist lateral forces like wind and seismic activity. There are different types of braced frames, such as X-bracing and K-bracing, each designed for different needs, but they all work by converting lateral forces into tension and compression within the braces. What is a moment-resisting frame? Now, let's talk about the moment-resisting frame system. Unlike braced frames, moment-resisting frames don't use diagonal braces. Instead, the joints between the columns and beams are specially designed to resist rotation, meaning they carry bending moments as well as vertical loads. This system provides flexibility in design and allows for more open spaces, since you don't need diagonal braces to block off walls or windows. However, it relies heavily on the strength of the beam-column connections to resist lateral forces. So, what makes braced frames a good choice? The biggest advantage is their high stiffness. Braced frames are excellent at resisting lateral forces, making them a common choice in areas prone to earthquakes and high winds. They're also typically more cost-effective because braces are easier and faster to install than reinforced beam-column joints. However, one downside is that braced frames can restrict architectural design. The diagonal braces often limit where windows, doors, or open spaces can be placed. Now, let's look at the strengths and weaknesses of moment-resisting frames. These frames offer more design flexibility because there are no diagonal braces. This is ideal for buildings that require large, open spaces or where aesthetics are a priority. Moment-resisting frames also allow for more natural light because you can have larger windows or open facades. However, the construction of these systems is more complex and expensive. The joints between the beams and columns need to be carefully designed and reinforced to handle both vertical and lateral loads. Braced versus moment-resisting frames. When to choose. So, how do you decide which system to use? If you're working on a building where lateral stability is the top concern, like in earthquake-prone regions, a braced frame is often the better choice due to its stiffness and cost-effectiveness. But if your project requires flexible design and large open spaces, like in modern office buildings or high-rises, a moment-resisting frame may be worth the extra investment. In the end, both systems play a crucial role in keeping buildings safe and stable. Your choice depends on the balance between design flexibility and lateral strength. Thanks for watching Blueprint to Reality. Don't forget to like, subscribe, and hit the bell for more engineering insights and solutions. Welcome to Blueprint to Reality. Today, we're exploring groundbreaking innovations in earthquake dampers, specifically base isolators and tuned mass dampers, and how they help protect buildings from seismic vibrations. The challenge of earthquakes. Earthquakes are unpredictable and can cause severe damage to buildings by shaking them from their foundations. Traditional structures transfer these forces directly from the ground to the building, leading to cracks, collapses, and structural failures. But innovations like base isolators and tuned mass dampers are revolutionizing how we build to withstand seismic events. Base isolators. Let's start with base isolators. These devices are installed between a building's foundation and its structure, acting as a buffer during an earthquake. Instead of letting the building move with the ground, base isolators allow the foundation to shift independently from the rest of the structure. This reduces the amount of force transferred to the building, dramatically lowering the risk of damage. Base isolators typically consist of layers of rubber and steel with a flexible core. When seismic waves hit, the isolators absorb and spread out the energy, allowing the building above to sway gently without absorbing the full impact. Tuned mass dampers. Now let's talk about tuned mass dampers, another powerful innovation. These are massive weights, usually installed at the top of a building, that move in opposition to seismic vibrations. When an earthquake shakes the building, the damper swings in the opposite direction, effectively canceling out much of the motion. Tuned mass dampers are carefully calibrated or tuned to match the building's natural frequency. This tuning allows them to absorb and dissipate the energy from seismic vibrations, preventing the building from swaying too much and reducing structural stress. How they work together. Together, base isolators and tuned mass dampers create a powerful defense against earthquakes. Base isolators protect the building from ground motion, while tuned mass dampers reduce vibrations in the upper structure, making the building safer and more resilient. Innovations like these are changing the way we design buildings in earthquake-prone areas, saving lives and protecting property. Thanks for watching Blueprint to Reality. If you're fascinated by how engineering solves real-world challenges, don't forget to like, subscribe, and hit the bell for more exciting insights. Welcome back to Blueprint to Reality. Today, we're discussing an important topic for anyone planning to build a home. Things you need to know before starting your project. Whether it's your dream home or a practical space, these tips can help you avoid common pitfalls and make informed decisions. First and foremost, let's talk about budgeting. Building a house can quickly become expensive if you don't have a clear plan. Make sure you include everything in your budget: construction materials, labor costs, permits, landscaping, and even unexpected expenses. It's also a good idea to set aside an additional 10 to 20% for contingencies, as surprises are common in any construction project. Next, consider the location. The land you choose can significantly impact your design and cost. You'll want to check the zoning regulations and local building codes in the area. These will dictate what type of structures you can build, how close to the property line you can go, and what environmental considerations need to be accounted for. Also, think about the future. Access to schools, shops, and transportation can affect long-term value. Design is crucial, not just for aesthetics, but for functionality. Before jumping into the architectural phase, think about your lifestyle. Do you need a home office? What about a guest room or space for future expansions? Pay attention to the layout and flow, how rooms are connected, natural lighting, and storage solutions. Work closely with your architect or designer to ensure the home meets your present and future needs. Building a home requires a team of professionals, architects, contractors, and engineers. Do your research and hire a licensed, experienced contractor who has a good reputation. Don't rush the process of selecting your team, and be sure to check references and past projects. A well-coordinated team can save you time, money, and headaches down the line. Finally, set realistic expectations for your timeline. Construction projects often take longer than expected due to weather, material delays, or labor shortages. Be patient and flexible with your schedule, but also stay involved and keep communication open with your team to ensure things are moving forward. Building a house is a big undertaking, but with the right preparation, it can be a rewarding experience. Keep these tips in mind to stay on track. If you found this video helpful, don't forget to like, subscribe, and hit the bell icon for more home building and construction tips. Thanks for watching, and see you next time on Blueprint to Reality.